Myself, P. Isaradabalan, Assistant Professor, Department of Civil Engineering, Rogini College of Engineering and Technology. Subject Engineering Mechanics. So today topic is center of gravity and moment of inertia. First one, centroid and center of gravity. In general, when a rigid body lies in a field of force act on each particle of the body, we equivalently represent the system of forces by single force acting at a specific point. This point is known as the center of gravity. Various such parameters include center of gravity, moment of inertia, centroid, first and second moment of inertia of a line or a rigid body. These parameters simplify the analysis of structures such as beam. Further, we will also study the surface area or volume of revolution of a line or area respectively. Centered of area and a line. The one method to find out the center of gravity, there are other ways too. Let's consider plate of uniform thickness and homogeneous density. Now, the weight of small element is directly proportional to its thickness, area and density. The del W is equal to del T into dA, where del is the density per unit volume and T is the thickness, dA is the area of small element. Then moment of inertia. First, what is a moment of inertia? It is a measure of an object resistance to change to its rotation, also defined as the capacity of cross section to resisting bending. It must be specified with respect to a chosen axis of rotation. It is usually quantified in meter power 4 or kilogram meter square. Perpendicular axis theorem. The moment of inertia of a plane area about an axis normal to the plane is equal to the sum of the moment of inertia about any two mutually perpendicular axes lying in the plane and passes through the given axis. That means moment of inertia I is equal to Ixx plus Iyy. Then parallel axis theorem. The moment of inertia of an object about any axis parallel to the centroidal axis is the sum of moment of inertia about its centroidal axis and the product of area with the square of distance of from the reference axis. Essentially, Ixx is equal to Ig plus A into d square. A is the cross-sectional area, d is the perpendicular distance between the centroidal axis and parallel axis. Next, parallel axis theorem, that is the derivation. Consider the moment of inertia Ix of an area A with respect to an axis AA. Denote by y the distance from an element of area dA to AA dash. Ix is equal to integral y square dA. Derivation, consider an axis BB dash parallel to AA dash through the centroid C of the area, known as centroid axis. The equation of the moment of inertia becomes Ix is equal to integral y square dA is equal to integral y dash plus d the whole square dA. Therefore, the integral y dash the whole square dA plus 2 into integral y dash dA plus d square integral dA. Modify the equation obtained with the parallel axis theorem. Ix is equal to integral y dash square dA plus 2 integral y dash dA, that is cancel, plus d square integral dA. Therefore, Ix bar plus d square A. Then radius of gyration of an area. Radius of gyration of an area A with respect to the x-axis is defined as the distance kx, where Ix is equal to kx into A, with a similar definition for the radii of gyration A with respect to the y-axis. With respect to O, we have k is equal to root of ix by a, or ky is equal to root of iy by a, or k naught is equal to j naught by a. Thank you.